an introduction to exponential function. What is an exponential function? An exponential function is a classification of functions where the independent variable or the input data is represented by the variable x, and x is an exponent. For example, f at x is equal to 3x, and that represents an exponential function. Note, f at x means f of x and is another way to write a function. Up we go. What information is given in the equation? Let's look at the example y equals 2x. The 2 represents the base of the exponent, and x represents the exponent, the variable, the unknown. If we have y equals 1/2 x, 1/2 is now the base, and x still represents the exponent. Working with the base. In the first example, the base was 2, and in the second example, as 1/2. What is the difference? Let's look at a graphical representation to explain this. Graphical representation number 1. This is the graph for the function y equals 2x. Since the value of y is increasing, this function represents growth. Key points include the y-intercept at 0, 1, but it has no x-intercepts. Some key points we could use: point 1 at 1, 2, point 2 at 2, 4, point 3 at 3, 8. And we notice the y values are increasing. Graphical representation number 2. This is the graph for the function y equals 1/2 x. Since the value of y is decreasing as you move from left to right, this function represents a decay. The key points include the y-intercept is 0, 1. There are no x-intercepts. And point 1, negative 3, 8. Point 2, negative 2, 4. Point 3, negative 1, 2. So we can see as x moves from left to right, the value of y is decreasing, which makes it a decay. Now for a summary. 2 to the x, 2 is the base, x is the exponent. If the base is greater than 1, the function represents growth, increasing values of y. If the base is between 0 and 1, the function represents decay, or decreasing y values, moving from left to right. The summary: 2 to the x, base, exponent. The base represents the growth or decay rate. If the base is greater than 1, the base represents the growth rate. If the base is between 0 and 1, the base represents the decay rate. Now, here is a sample question. Number 1. Does the equation y equal 4x represent growth or decay? Verify your answer. Solution. The base is 4, the variable is x. Since the base is greater than 1, this equation represents growth. This is the graphical representation that represents the function y equals 4x. Key points: 0, 1, 1, 4, 2, 8. Clearly, this is growth. Y is increasing. Sample question number 2. Does the equation y equal 1/4 x represent growth or decay? Prove your answer. Solution. The base is 1/4. The variable is x. Since the base is greater than 0 but less than 1, this equation represents decay. Sample question number 2. Proof. The graph displayed represents the function y equals 1/4 x. The key points -2, 16, -1, 4, 0, and 1 show as you move from left to right the graph is decreasing, which makes it decay. Remember, exponential growth, exponential decay.